Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by forcing the equation into standard form, complete squares if needed, and divide to get denominators. Once done, read the center h, k from the shifted terms and decide orientation. If x term is positive, transverse axis is horizontal. If y term is positive, it is vertical. Make sure to identify a 2 and b2 exactly from those denominators, because calculating c depends on them. This gets you the essential constants for the next step. Next, compute the focal distance c by using c squared equals a squared plus b squared, that is c2 equals a 2 plus b2, then take c equals sqrt, c2. Understand why. For hyperbolas, the foci lie along the transverse axis beyond the vertices, so c must be larger than a. Once you have c, decide how it affects coordinates. For a horizontal transverse axis, you will shift the center horizontally by plus or minus c. For vertical, shift Finally, place the foci by shifting the center by c along the transverse axis. If horizontal, the foci are h plus c, k, and h minus ck. If vertical, they are h, k plus c, and h, k minus c. Once done, verify by confirming the distance relation to vertices or by substituting focal coordinates into the hyperbola geometry. If results look wrong, recheck your standard form algebra, ensure you didn't swap a and b, and confirm c was computed as sqrt, a 2 plus b2.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.